Hello, hello, hello. Welcome to the June 2016 Algebra 2 Regents or Common Core exam. This is part of a review. This is the third video, and we are going to do problems 17 through 24. I'm flying a little high this morning because it is Teacher Appreciation Week, and our parent board actually brought in donuts. So I'm one donut in. This is only first period. I will probably be 5 donuts in come sixth period. I'm teasing. I can't. I've got to watch my figure. Anyways, they didn't have any Boston cream, which I was bummed about. They have the white cream, but you know, it's not Boston cream, let's face it. So I went to the old reliable number 2, double chocolate, and it was fantastic. All right, let's start with number 17, shall we? A circle centered at the origin has a radius of 10 units. If you watched any of my videos, you know I like to draw and I like to make a picture. There is a set of axes. The origin is the center of the circle. And the circle has a radius of 10. So let's say this is 10, this is negative 10, this is 10 on the x-axis, and negative 10 on the y. Okay, my circle will run through all those points. All right. Excuse this messy, sloppy circle. Yeah, that didn't even touch that one. And it looks more like Stewie's head from Family Guy, but hey, we'll work with it. Now, the terminal side of angle theta, all right, intercepts this particular circle in quadrant 2. This is quadrant 2. All right. So if I were to draw an angle, let's call it theta, it intersects at point C. Let's call it maybe right here. Who knows? Bam. This is point C. The y-coordinate of point C is 8. So this is up 8, okay? So if I were to make a triangle, that is actually a height of 8. All right? So they ask us, what's the cosine of theta? All right, this is a great problem, and it deals with trig and the unit circle and everything we know. So in order to find out sine or cosine or tangent of an angle, especially in a right triangle, because that's what we have here, we have a right triangle, it's nice to know the sides. I only have one of them, 8, but actually I have 2 of them. The radius of the circle is 10. This line right here is also a radius from the center to the circle. That is 10 as well. Okay? So if I need to know the cosine of this angle right here, cosine is cos another hoe. All right? So according to my yellow angle here, this is opposite, this is hypotenuse, this bottom is adjacent. So how do I figure out the third side of a triangle if I'm given 2 sides of a right triangle? Our old friend, the Pythagorean Theorem. The only rule with the Pythagorean Theorem is as follows. The hypotenuse, which happens to be the radius here, 10, needs to be your C value. So 10 squared equals, we'll call this 8 squared, because that's one side. And we're solving for A. That's going to be our third side. So let's clean this up. A squared plus 64 equals 100. I am going to subtract 64 from both sides. And of course, you guys know you have a calculator, so there's no way in God's green earth you should mess this up. And you should know what 8 squared and 100 squared is anyways. So 36. And I don't want A squared. I want A. So I still need to take the square root. And that tells me that my side has a length of 6. So I put 6 here. And if cosine is adjacent over hypotenuse, here's adjacent, 6. Here's my hypotenuse, 10. So I could say, oh, 6 over 10. That reduces, Visca, 3/5. And you'll sit here and you're going to circle 3. That's wrong. Yeah, I know. I threw that one right in your face. So why is that wrong? Remember our old adage here? All students, we'll keep it clean, take calculus. Okay? What these letters represent are which trig functions are positive in those quadrants. Okay, so sine is the only positive trig function in quadrant 2. Cosine and tangent are both negative. Aren't we taking the cosine? We are. Shouldn't it be negative? It should. So this is negative 3/5. Okay, so the correct answer is number 1. Number 18, which statement about the graph of c of x is false? And c of x is actually log base 6 of x. Now, the first thing I would do, you can see all of our options here. Let's read them. Number 1, the asymptote has an equation of y equals 0. The graph has no y-intercept. The domain is the set of positive real numbers, and the range is a set of all real numbers. All right, I'm telling you, I would absolutely graph this thing and look at the graph. That is going to be your one go-to moment here. Okay, you have a graphing calculator, so use it. Right? Let's clear this out. Let's go to y equals. I'm going to clear this out. Oh, look at that. There's an imaginary number in there. What was I doing? Okay, so let's go to log base. Now, first thing, quick reminder, if I hit this number or this button right next to the number 7, that's just log. If I press that, you'll notice it doesn't allow me to put a base in here. You need a base 6. If you just type the log button, that is going to assume that you want log base 10, which is the default base for log. All right, we don't want that. So where do I go to log base? Some people say hit math, and if you scroll down here, you can hit math, then A. Or, I like the shortcuts. I hit alpha window, and it's right there, number 5. Okay, so either way, once you hit log base, now it allows you to put the base in. So, let's go back to y equals. Let's put log base in. Log base 6 of x. Yep, that's okay. I would delete that and move that. And then move that. There you go. X. Next. And I'm going to graph that. All right. So look, it looks like it kind of hits here and stops. Let's zoom in a little bit. Okay. Let's do this. I know it's going to go up up and to the right forever and slowly increase. It goes further and further this way. So I'm more focused about what's going to be happening here. So if I want to hit zoom, I'm going to zoom box. I love using the zoom box. So I go here and I'm going to box all these things here. I'm going to start here, go over, and then scroll down here. And hit enter. And that's what I'm going to zoom at. And it still looks like it stops. It's weird. So what am I going to do? I'm going to look at my table. And I'm going to see when x gets really, really close to 0. Does it actually touch the y-axis or not? Because that's what I'm not sure of. I know as a math teacher what happens. But let's go to my table. Okay. Bam. And when x is 1, y is 0. But what about in between 1 and 0 here? Okay. So I'm going to make the table change. I'm going to start at 0. And I'm going to make a change by 100th. So I can get within 100th, 100 times closer, if you will. If I look this, oh, look, see, we do have y values, okay, at 0.1, they're negative y values. So the smaller I get, the closer I get to 1, these y values will still be negative. They're just so close to the y-axis you can't see them, okay? So let me go to table set again. I'm going to start at 0. I'm going to make it 10 thousandths. Okay, I'm going to look at my table. Geez, look at that. See, -5, -4. So it doesn't actually touch the y-axis. It just looks so close that it looks like it just becomes the y-axis. But in all reality, and this is the tough problem because this graph really kind of helps but doesn't. Okay, it goes like this and it gets so close. Okay, it just looks like it becomes the y-axis, but that's what it does. It gets closer and closer without touching it. So let's take a look at all these responses and interpret them and see which one is false. Don't just circle the first true one. 3 of them will be true. All right? This graph has, well, let's start at the bottom. The range is a set of all real numbers. Yeah, this graph goes up. It crosses the x-axis, and it goes up forever, slowly. So it goes to positive infinity on the y, and obviously it goes down forever, so it goes negative infinity. Range is all y values. That definitely goes up and down forever, so that is all real numbers. That's true. Now, number 3, my domain, that is x values, is the set of all positives. Okay, well, the domain never hits 0 here on the x-axis, okay? It goes just barely in front of 0 and this way forever. You can see it goes to the right forever. So that's all the positive values in the x-axis. Positive reals, that is true. The graph has no y-intercept. Does it touch the y-axis? No, it doesn't. So it does not have a y-intercept. That is also true. My answer is 1. The asymptote occurs at y equals 0. So what does that mean? That means it has a line that it gets really, really close to but doesn't touch. And that line's equation is y equals 0. Okay? Y equals 0. The asymptote, excuse me, that's a false thing. Did I say true? I said that's the right answer. Okay? This horizontal line is y equals 0. Okay? That's not an asymptote because it touches it right here. Okay? It crosses it right there. So this is definitely false. That was a tough one to interpret. Kind of got to know what you're looking at on a calculator, especially when it doesn't really show you everything. Tough one, but you got it now. Number 19, our old friend completing the square rears its ugly little face. The equation 4x squared minus 24x plus 4y squared plus 72y equals 76 is equivalent to what? Okay, I've got to do completing the square to both my x's and to my y's. All right, I don't have to solve it completely, but I really just need to set it up so that I have, okay, 2 perfect squares in there. All right, and that's exactly what we're going to do. So let me rewrite this and we'll start moving. 4x squared minus 24x plus 4y squared plus 72y equals 76. Now, one thing I notice in all my answers, they factored out a 4. Okay, so I'm going to do that to both my x's and my y's. Okay, if those are what the answers look like, I'm absolutely going to do what they look like. I mean, that's the quickest way to get there. So I'm going to factor 4 out of these two. And what's left is x squared minus 6x. Okay. I'm also going to factor a 4 out of my y's. That would be y squared, and 4 goes into 72 18 times. Equals 76. All right, so now this is the golden ticket. This is the main operation for completing the square. If you forget this, there's no way you can do completing the squares. Okay, I need to take my b value. Okay, I take my b value, I cut it in half, and then I square it. And that's the number that I add to both sides. So I need to do that for my x's and for my y's. So I have negative 6. These are for my x's. I have negative 6. I cut it in half, and I square it. Now, many of you can just get that number. That's going to end up being 9. But what I tell my students is I simplify the parentheses first. That's negative 3 squared, and then I get 9. And I will explain why this number is important in a moment. Okay, so I'm going to add 9 to this side, and I need to add 9 to this side. Now, notice I'm leaving some space in front of the plus and the 9. There's a purpose for that. Okay, let's do the y value. Okay, I'm going to take 18, cut it in half, and square it. Well, that's 9 squared, which is 81. Okay, so now I'm going to add 81 inside this parenthesis, and I've got to add 81 here. Notice, again, I'm leaving some space between the 81 and the plus sign. So, when everything's all said and done, I now have 4 times x squared minus 6x plus 9 plus 4 times y squared plus 18y plus 81 equals, I'm going to add this down here. Now, here's the issue. I'm not just adding 9 and 81. If I were to FOIL this back in, aren't I ultimately multiplying 4 times 9? Technically, it's 36. 4 times 9. And 4 times 81, oh my God, it's 324. All right? So if I just add 9 and 81, that's not going to balance, okay, because my 81 is being multiplied times 4. My 9 is being multiplied by 4 here. I'm not multiplying by 4 here, so it's not going to be balanced. So I need to multiply these numbers by 4, okay, and get that total. You absolutely have to do that, okay, because that's the balance we need to keep life good and black holes from preventing opening up right next to Earth. Now, we have 76. I'll do this. Yeah, you know what? You got a calculator. What the heck? Turn this on. Get out of this ugly little graph here. 76 plus 4 times 9, which is 36, plus 4 times 81, which is 324, but let the calculator do it for you. And you get a total of 436. That's what my equation is equal to. Now we got to realize we've just created perfect squares here and here. That's why this whole process is called completing the square. We have 4 times, I know this is an x and it's something squared. This is where these numbers come into play. Whatever number is in parentheses here is the same number that's going to be in parentheses here. I mean, you should know how to factor that, but even if you didn't, the number's in front of your face. Okay, plus, now let's look at my y's. I know it's y plus or minus something squared. Well, whatever number is in parentheses here, it's a positive 9, goes right here. Okay, plus 9. And whatever, again, highlighted, what was here went in parentheses here. Okay, so they rear their faces again, and that equals 436. And this is one of my options. Okay, if I did that right, the only one that looks like it adds 436 to the bottom is number 4. And that's exactly what we came up with. All right? Not horrible. You just got to remember completing the square. They threw that little trick in there, though, with, you know, it's 4 times 9 you're technically adding. It's 4 times 81 you're technically adding. So that's why you need to multiply this side by 4 as well. Number 20. This one is a very, very easy one as long as you know certain terminology and certain characteristics of graphs. Okay. Number 20 says, there was a study done on oxygen consumption of snails as a function of pH. Okay, I don't know. Who has no time in their life to do anything except this? That would be nuts. And the result was a degree 4 polynomial function whose graph is shown below. Okay, we have this here. I have this graph. It's nice. Okay, it kind of goes up, down, up, back down. So it starts down and ends up down. So which statement about this function is incorrect? Okay, so 3 are going to be true. 1 is going to be false. We want the one that's false. The degree of the polynomial is even. I know that is true or that is correct because any even degree means that the lead term has an even exponent. That means it behaves kind of like a parabola where both ends will either be up or both ends will either be down. Okay, it depends. If my lead term is negative, it opens down. If my lead term is positive, it opens up. The middle, it doesn't matter. Okay, I could do this and it could do blah, 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 like that. That's fine. That would still be something with an even degree. This would be negative because it's open down. All right, it's just the end behavior. So I know that's true. Number 2, there is a positive lead coefficient. Oh, I think we just answered the question. If it were positive, both of them would be opening up. This opens down. There is a negative lead coefficient. This is false or incorrect. All right. Let's take a look at 3 or 4 because someone in class always asks me, well, what about the other 2? Can you explain those? Yeah. It's saying at 2 pH values, there are relative maximums. This has 2 maximums. Remember, maximums are hilltops. Okay, maximums. There are 2. There's one here, and there's one here. Those are 2 hilltops. Okay, so this is true. There are 2 intervals where the function is decreasing. That means that it has a negative slope. So as it moves to the right, it goes down. Okay, this is all positive, positive because it's going up and to the right. Boom. And now, uh-oh, look at that. Down. That's a negative part. Then it goes back up, 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 and then down, negative. So those 2 red highlighted areas are two places where the function is in fact decreasing because it has a negative slope. So that is true as well. All right, easy one, as long as you know what you're doing when it comes to even and odd degrees. Number 21. Last year, the total revenue for Homestyle, a national restaurant chain, increased 5.25% over the previous year. Ooh, I smell an exponential. And looking at the answers, it absolutely is. If this trend were to continue, which expression could the company's chief financial officer use to approximate their monthly percent increase in revenue? Let M represent months, okay? So as I look at all my possible answers here, this exponent is in months, okay? M represents months, all right? So we need to set up an equation based on what we have, all right? Their revenue increased 5.25% over the previous year. So right now, okay, if it's increased, it's 1 plus your rate raised to time. I'm just going to use these variables because that's what we're used to. Okay, the rate, 5.25%, needs to be in decimal, meaning without the percent, which means I slide this over twice. So it's 0.0525. That is what's going in for R. So it is 1 plus 0.0525. And if I add those, it's 1.0525 raised to time. Now, you might be saying to yourself, oh, okay, it's number 1. It is not. Right now, my exponent is in years. That 5.25% was for a year. Okay? We need months. All right? So they put that in there, number 1, to see who's going to fall for it. So here's the $1 million question. If time is in years, it's 1 year, how do I get this to represent 1 month? Well, 1 month is a year divided by 12, right? There are 12 months in a year. So I take my year and I divide it by 12. I can say T over 12. Now that equals a month because it's a year divided by 12. Or I can say 1/12 times time. Either one of those is fine. So what I'm going to do is I'm going to use this one because that's going to help us get, you could use this one. It wouldn't be wrong. Okay. So now I have 1.0525 times 1/12t. Now my exponent represents months. Okay. This one was years. Now, bam-o, that one's months. All right. Okay. I don't see that answer anywhere either. Okay. Number 2. Oh, is it number 2? No. For number 2, the 12 is on top. We want the 12 on the bottom. Okay. So it's not 1 and it's not 2. If I want to get months by, oh, look it's here, but notice the inside is not the same. Okay, so technically by those, you know it should be 3. But let me finish off this problem and explain something. If I truly want to know how much money I increased per month, that means I need to get my exponent, which is now in months, alone. Okay. So I'm going to apply this 1/12 to my base. Okay, and whatever I get when I apply, oh, I love you, highlighter. Whatever I get when I apply this 1/12 is now going to be my new base. And this t, that variable, even though it's a t, since I took 1/12 out of it, will now represent months. Okay, forget the fact that it's t and not m, but it will represent months. Okay, so if I turn on my trusted calculator, I take 1.0525 and I raise that to 1 divided by 12. And look at that, 1.00427. This is my rate when my exponent represents months. Bammo. Not too bad. Number 22, to the nearest tenth, which value is not a solution? of P of X equals Q of X. So when this one is equal to this one, you cannot do this algebraically because, I mean, there are ways, but not for you guys. Because well, if you get everything to one side, you're not going to be able to factor this and get these decimals as factors if you booty, cheek, and T-bone by grouping or whatever. So put them both in the calculator and see where they intersect. Chances are they're going to intersect in 3 spots. One of those is not a solution. 3 of them are. So let's go ahead and do just that. Again, calculator. Woo, we love it. So I'm going to graph both of these, this one in Y1 and this in Y2. Let's go here, clear this out. Oh, log base, so silly. I'm going to put x cubed, right, plus 3x squared minus 3x minus 1. And I go down and I'm going to put this into Y2. Okay, 3x plus 8. All right, I'm going to zoom. I'm going to make sure I go to standard because that always puts me back to my 10 by 10 window. Let's see. Oh, that's a nice little doohickey. And there it is. Okay, crosses once, it crosses twice, and it's going to cross another time up here. So let's kind of include this window. So let's increase our y. Okay, so if I go to my window, instead of going up to 10 on the y, let's call it 20. That should be more than enough. Oh, now I see way more y's up here. Oh, beautiful. 1, 2, 3 intersections. Let's figure out those x values. Second, calculate, which is above trace, intersect, 5. We just go to the closest ones. So I'm going to go start with this one way down here. Move my little buggy guy right there and hit enter 3 times. 1, 2, 3. Negative 3.9 is a solution. So this one is a solution. Let's do the next one. Second, calculates intersect. I'm going to go to the middle one now. Come on. I hit enter 3 times. 1, 2, 3. Negative 1.1 is a solution. That's choice 2. So 1 and 2 are both solutions. So this one right here is either 2.1 or 4.7. It looks like 2.1, but let's let the calculator tell us. Do the same thing, and I'm going to move so much closer. And I'm going to hit enter 3 times. 2.1 if I round, because that's 5 or bigger, so that will round up to 1. Number 3 is also an answer. So the one that is not an answer is choice 4. I love these problems. 23. Love it. The population of Jamesburg for the years 2010 through 2013, respectively, were reported as follows: 250,000, 250,937, 251,878, and 252,822. How can this sequence be recursively modeled? If it's recursive, they have to give us the first element. They have to give us J1. They have to, okay? Then they give us something else to figure out all the other ones, okay? They have to give us our beginning element. This has to be given. That is one of the definitions of recursive. Notice that 3 and 4 give us J1. Since it's recursive, I know it's either 3 or 4. It can't be 1 or 2. Now, let's just check 3 or 4. I'm going to try 4 because it seems easier, okay? If and what this is telling me is I take my previous number and all I do is add 937 to it. So if I want to figure out how to get my second term, I take my first one and add 937. If I take 250,000 and add 937, I do get this, 250,937. Let's try this one. Okay, how do I get this? I take the previous number and I add 937 to it. So 250, 937, and I want this, so I add 937 to it, okay? 4, I carry the 1, 6, 7, 8, 1, 251, 874. That is not this number, okay? This would be the third term according to number 4. It would start 250,000. Then it would go 250,000, 937. Okay, that's good. That's good for these two. But my third term should be 874, and it is not. Okay, so it can't be this. It's choice 3. So you might ask me, well, how would we do choice 3? How can I check that algebraically? Well, all it's telling us to do is take our previous term and just multiply it by 1.00375. So in order to get this, I take 250 and I multiply it by 1.00375, and I do get this number. How do I get this? I take the previous term and I multiply it by 1.00375, and I do get this, and so forth to get the next one. So number 3 is your answer. But I love that it says recursive, and you can cross off 1 and 2 because it does not give you the first element, J1. So now if you were a guessing man or guessing woman, instead of 1 out of 4 shot, you literally have a 1 out of 2 shot, which is good. Good odds. Last problem, and guess what? I hate it. When I first started doing this problem, even I got it wrong. I'm like, what? What is this witchcraft and sorcery? And then it turns out it's just the way it's worded. To me, it's confusing. But let's try and make sense of it, okay? The voltage used by most households can be modeled by a sine function. The maximum voltage is 120, okay? So whenever we talk about mins and maxes, I know, according to an equation, a trig equation, that's my amplitude, all right? And look at all of these have an amplitude of 120. So I cannot cancel any of these out yet, okay? There are 60 cycles every second, and I think the word cycles is what throws me off. Because once I see that, I automatically want to say, oh, frequency, 60, good, but that's not the answer. Okay, that is not the answer. All right, and I see a 60 here. That's not the answer either, but let me explain how, because you can't just cross those off just by seeing that. Okay, so which equation best represents our situation here? All right. Well, if there are 60 cycles every second, what's the length of one cycle? That is 1/60th. Okay. All right. Let me say this again. If I have 1 second here, okay, 1 second, and I have 60 cycles, blah, 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 each cycle is 1/60th of that second. That is the period. I need the frequency to find this out. I find the frequency by taking 2 pi and dividing it by the period. So if I take 2 pi and divide it by my period, what do I do? How do I simplify that? I multiply the bottom by 60. Gets rid of this. I also multiply the top by 60. 2 times 60 is 120 times my pi. And that's my frequency. And that's where I think most people would have, okay, there's my 120 pi. That's where most people, I think, would have struggled, including myself when I first read this. And it all has to do with this word cycles here that threw me off. All right? We are done with this video. The next video, we are going to start the part 2s, the short answers. Let me see. Yes, we are. And I hope to see you then. See ya.